All right, so now we're going to talk about rectangles. So the basic definition of a rectangle is here. A quadrilateral is a rectangle if and only if it has four right angles. So that's the requirement to be a rectangle. So it has to be a quadrilateral. We already know it's a parallelogram, but it is specifically a rectangle if it has four right angles. Okay, now the rectangle's diagonals theorem says a parallelogram is a rectangle if and only if its diagonals are congruent. So on a parallelogram or a rhombus, the diagonals aren't necessarily the same length. But what they're saying here is that if you have a rectangle and you draw in the diagonals, then this diagonal right here is going to be the same length as this diagonal, like the whole distance of the diagonal. It's not talking about bisecting or cutting it or anything. It's just saying that, hey, these two diagonals are congruent. All right, so pretty easy facts about a rectangle. Let's go apply them to some problems. So this first rectangle practice problem says, in example 1, rectangle QRST. All right, QS is this distance right here. So QS is referring to a diagonal, and it is 5x minus 31. Now RT is referring to the other diagonal, which is right here, and it is 2x plus 11. So it says, find the lengths of the diagonals of QRST. Well, we know, based on the rectangle diagonals theorem, that the diagonals are congruent. So how would we set up this problem? All right, since the diagonals are congruent, we would say 5x minus 31 is equal to 2x plus 11. And now let's go ahead and solve for x. All right, so we have 3x minus 31 equals 11. Add 31. So 3x equals 42. And then divide by 3, and we get x equals 14. Now we're not quite done. How long would the length of the diagonal be? Okay, so 14 is not your answer because you need to go ahead and plug it in to find the actual length of the diagonal. So choose either 2x plus 11 or 5x minus 31. So when I plug it into 2x plus 11, I get 39. That's the length of RT. Now if I want to go ahead and try to plug it in to 5x minus 31, I also get 39, and that's the length of QS. And it's a good self-check because we know that if they are congruent, then we have more confidence that we did our problem correctly. All right, example 2 is talking about building a frame for a window, so like the opening you're putting the window into. So it says the opening must be a rectangle. Given the measurements in the diagram, can you assume that it is? So look at what you know. You know that 2 of the sides are 33 and 2 of the sides are 44. So in our facts of how do we know if something's a rectangle, the definition says you must know that it has 4 right angles. Well, all we know is opposite sides are congruent, and that's enough to prove a parallelogram, but not specifically a rectangle. So I'm going to say no. We don't know. It could be, but we don't know. And when it says explain your reasoning, my reason is it needs to have 4 right angles. And that this could just be a parallelogram. All right, so a follow-up question is, you measured the diagonals of the opening. The diagonals are 54.8 inches and 55.3 inches. So one's 54.8 inches and one's 55.3 inches. So it says, what can you conclude about the shape of the opening? Well, keep in mind, this says that a parallelogram is a rectangle if and only if its diagonals are congruent. So remember, when it's a biconditional with if and only if, we can think of this in 2 ways. First, we can think to ourselves, I'm just going to kind of jot this down shorthand. If a shape or a parallelogram is a rectangle, then its diagonals are congruent. Well, we can go backwards on a biconditional. So if the diagonals are congruent, then that proves that the parallelogram is a rectangle. So that's kind of like the forwards and the backwards, the if-then statement, and then the converse of it. And so basically, if we know the diagonals are congruent, then we can say, hey, yeah, that's a rectangle. So if the diagonals are not congruent, that's enough to say it is not a rectangle. So we're going to say not a rectangle. Nice try, though. Because the diagonals are not congruent.